Earlier this week, I talked about the movie Worth and how I thought it really underscored the concept of customer empathy and how critical it is in all of the work that we do, building products, dealing with users, dealing with customers. Now, customer empathy is one of the 8 InVision principles. It's principle 6, although I think it should be principle 1, but that's aside. And as I was talking about the customer empathy principle earlier this week, it occurred to me that it might be a perfect opportunity for me to explore the CSS Scroll Snapping properties within HTML. I had this vision of creating a full screen card experience, and as I would scroll up, you'll see that the cards snap into place, creating a rich full screen experience. This is me with the mouse. Now you can see I'm going to do it with the keyboard commands. It's actually much nicer with the keyboard commands. And I can scroll down and I can scroll up. And you can see that the card experience is snapping into place. Now, if we look at the HTML, what we'll see is that I have a UL here, and actually Chrome calls out the fact that it is using Scroll Snap. And so it's set up to use Scroll Snap, and we can see that the Scroll Snap type here is Y mandatory. And what that means is that we're going to be snapping in the Y or vertical axes. And mandatory means that the browser has to attempt to snap the child elements into place after the user's scroll operation has completed. Now, the UL element here you can see is position fixed, and I'm using 4-sided positioning to take up the entire screen real estate. The LI elements now within the scroll snap container have scroll snap align start, and that means that the browser is going to try to snap the child to the top of the vertical axes in our scrollable viewport. And that's like literally all it takes to get this to work. It's pretty amazing stuff. I've never used it before, and I'm already just super impressed. The rest of the CSS here is all just has to do with the layout of the card, and you can see there's a bit of a responsive design. I'm not particularly good at responsive design, so that was a lot of trial and error. But I'm just loving how easy it is to get this to work with those essentially 3 properties: overflow, auto, scroll snap type, and scroll snap align. And just the power that we get over the user experience here is pretty amazing. You'll also notice that as I scroll down and up, the URL is changing. And I'm using the intersection observer API to watch the changes in which card is visible within the browser viewport. And then I'm taking the ID of that card and I'm using it to drive the fragment in the URL. You could also click the anchors here at the top, but I figured now if I refresh, it'll immediately be at the right card. Let's take just a quick look at how some of this works. So again, I mentioned that there's a UL and an LI. I at first tried to apply the scroll snapping concepts to the body itself, and I couldn't get that to work. And I don't know if that's just because I wasn't doing it right, or maybe there's a constraint where we have to have an explicitly overflowed element in order to get this to work. I'm not sure. This is the first time I've ever played with this stuff. So the scroll snapping is applied to the UL. The alignment is applied to the LI. As I mentioned, this is a fixed element here over the entire screen real estate. And then these LIs, if we look at the CSS for the card, it's set to take up 100 view height units. So view height shows us the each view height unit is 1%, I think, of the vertical space within the viewport. So I'm saying take up 100% of the vertical space in that viewport. And that's why we're getting this full screen experience. Now we can then leverage that full screen experience to drive the intersection observer API. So now let's scroll to the bottom here and let's get to the JavaScript. One thing that I had to do is I had to actually explicitly scroll the right card into place. So I look at the location hash. So I look at this hash and then use this hash as a query selector. So I'm looking for the ID or the element with this ID, and then I had to explicitly scroll it into view. Something was just buggy. I don't know why I had to do this. I feel like the browser should have just done this for me based on the fragment. I think it had something to do either with the scroll hash or with the fact that with the scroll snap, or the fact that I was using a fixed position element. I'm not 100% sure. I'll have to dig into that. But let's go to our setup intersection observer. So setting up the intersection observer is also relatively simple in this experience. I have my callback, which we'll look at in a second, and I'm using a threshold of 1. That means that the callback will only be invoked when the entirety of one of the cards changes its visibility or its hidden state. And because we're using a 100 VH or view height unit CSS here for the card, each card takes up 100% of the screen real estate, which means that we can safely use the threshold of 1 here to know when an entire card has either entered or left the viewport. So I then find all the cards and I tell the observer to observe each one of these cards. Now, if we look at the handler, again, because we know that we're using 100 view height units for each card, we know that at any moment, only a single card in this experience will either be, only a single card will be visible, all other cards will be hidden. So when we get the change of entries within the observer, we can loop over them, and we know that only a single one will have an is intersecting as true. At that point, we can take the ID out of that element and replace the current URL to make sure that the fragment matches the current user experience. Now, it seems like when you change the URL, the document loses focus. I had never seen that before, so again, maybe I'm just doing something wrong here. But I ended up having to call focus cards, again, to keep the keyboard navigation working, to keep the document focused. And that's how I get, as we scroll up here, again, you can see that the URL is changing based on the current state of the visible cards. So, I mean, there's relatively, here it's what, like 100 and 200 lines of JavaScript, maybe not, let's say 236 to 343. I mean, it's basically 100 lines of JavaScript and 3 CSS properties to get this entire experience working with the scroll snapping and the URL fragment change. I mean, that's kind of player. It's kind of player. It's amazing how far we've come in terms of what the browser will do for us. So just very cool stuff. And this was a lot of fun to play with.